Welcome back, guys. Today we're gonna solve this LeetCode medium level question, combination sum 3.
Toto down my shoes, Euro step my move. I just caught the ring, yeah my fingers hold on the finer things. That's just what I do.
In this question, we'll be given k and n as input, and we need to find every possible combination of length k so that every individual combination's summation is equal to 6. And for the combination, we can only choose number between 1 to 9, both inclusive. So the possible answer could be 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. Right, all of these make 6. But there are some more constraints. The constraints are like, we can't, if we have taken 3, we can't use 3 again in the same list. So this can't be in our possible answer. We have taken 2 and 4, so we can't take any other permutation of that also. So 4, 2 can't be in our answer 2. And we have taken 1, 5, so 5, 1 can't be in our answer 2. So the final answer would be 1, 5 and 2, 4. So by looking at this solution, the first thing that comes to our mind is we can make DFS calls and we can find every combination of length 2, and we can avoid the duplicacy by using set. And for the individual list, we can use a set or a visited array there too. But that could lead to extra space and extra time, right? So to avoid that, we can make a use of method called pruning. So for that, what we'll do is for first DFS call, we'll start the loop from 1 to 9, as we have to take numbers between 1 to 9 only. So first we'll take 1. So for the next DFS call, we'll take the number we have taken previously plus 1 to 9. Right, so the next number would be 2. So by this, we can avoid the duplicacy. So yeah, so let's see for this. So first we take 3 here, and the next DFS call, it will start from 4 to 9. So we can't take 3. So we have solved this. And for this and this, so we are taking 4 first. So the next loop will start, the next DFS call will start from 5 to 9 here. So we can't take 2, so this is solved. And for this, the next DFS call will start from 6 to 9. So this is solved too. So we avoided the duplicacy thingy, right? So now we have understood this. So let's just run through the algorithm. What I'll do is I'll have a temporary list in which we'll check every possible combinations. We'll have the result as the final answer. This will this is a list of lists, so we'll have the final answer here, and we'll have sum. So initially the sum will be 0. And what we'll do, the first DFS call will start from 1 to 9, right? And so the first DFS call will start from 1 to 9. So we'll take 1. And the next DFS call will start from 2 to 9, as we have taken 1 here. Yeah. And we have taken 1 in the first DFS call. So we'll add that to our temporary list. Now we move to the second DFS call. And here we'll add 2. And we'll add 2 to our temporary list again. Now our list's length is equal to k, right? And the sum will be 3. So we have to maintain the sum also. So initially it will be 1, and 1 plus 2 will be 3. So the sum will be 3, right? And our length is Yeah, so length is k. So we now check if our sum is equal to n or not. So 3 is not equal to n. 3 is not equal to 6. So we won't add 1 and 2 to our result, right? So we'll backtrack and remove 2 from the list. Now, so we have explored 2, we'll check with 3. And as we backtrack, we'll reduce that from the sum 2. So our sum will be 1 plus, okay. So now for 3, 1 plus 3, right? So 1 and 3 will be added to the temporary list also. Now we'll check 1 plus 3 makes 6 or not. So it doesn't. So we'll backtrack and remove that from the list too, and from the sum too. Right, now we'll check with 4. Does 1 and 4 make 6? No. So we'll remove that. Right. Now we'll check with 1 and 5. Does 1 and 5 make 6? Yes. So we'll add 1 and 5 to our final answer. Right. We found one answer. We need to check for other answers too. So we'll backtrack and remove that too. We have explored 5. Now we'll explore 6. Now 6 is greater than n. We'll just return. We'll not explore any further from there. And for 7, yeah, now we have 7. We explored 6. Now we have 7. 7 is also, so 1 plus 7 will also be greater than n. So we'll backtrack and remove that too. Yeah, now we'll check with 8. So that will be greater than an n2. We'll check with 9, that will be greater than n2. So we've explored the second DFS call. So we'll move back to the first DFS call and we'll backtrack and remove 1 from temporary list and the sum. And we have explored 1, so we'll explore 2 now. We'll add that to our list and to our sum. Right. And the next DFS, we'll move to the next DFS call. So the next DFS call will start from 3 to 9. Right. So we'll check with 2 and 3. Does 2 and 3 makes 6 or not? It doesn't. So we'll backtrack and remove that. We'll check with 4. Does 2 and 4 make 6? Yes. So we'll add that result. Add this temporary list to our result. So we got one more answer. Now we'll check if 2 and 5 makes, we'll backtrack and remove 4 first. And we'll check if 2 and 5 make 6. 2 and 5 is greater than n. So we'll just return. And now we'll check with 6. Does 2 and 6 make 6? 2 and 6 is greater than n. So we'll just return again. Likewise 2 and 7, 2 and 8, and 2 and 9 will be greater. So we'll just return back. Right. So we have explored the DFS2 again. We'll move from DFS2 to DFS1. And we have explored 2. So we'll remove 2 from list and 2 from sum 2. Now we'll check with 3. We'll add 3 to the list. We'll add 3 to the sum. And we'll move to the next DFS call, which will start from 4 to 9. So does 3 and 4 makes 6? No, it doesn't. So we'll just return back. Likewise, we'll return back from 5, 6, and 7, and 8, and 9. So this will continue, and we'll find that in the final answer we'll have 1 and 5 and 2 and 4. Right. So for this example, this is the possible solution. Now let's just look at one more example. So for k is equal to 3 and n is equal to 7, for this example, we'll first have temporary list. We'll have sum initialized as 0. We'll have the final result. Right. So the first loop will start from the first DFS call will start. We'll have the loop from 1 to 9. So we take 1 initially. We'll add that to the list. We'll add that to the sum 2. And we'll move to the next DFS call. The next DFS call will start from 2 to 9. So we'll add that to our list and to our sum. And we'll move to next DFS call because the temporary list's length doesn't equal to 3 yet. So the next DFS call will start from 3 to 9. So we'll add 3 to the list and 3 to the sum. Now we'll check as the list length is equal to 3. So we'll check if the sum is equal to 7 or not. The sum here is 6. It's not equal to 7. So we'll backtrack and remove 3 from the sum and from the list. Now we have explored 3. So we'll explore with 4. So we'll add 4 to the list and to the sum. And now the sum is equal to 7. So we'll add 1, 2, and 4 to our answer list. Right. And we'll backtrack and check if there is some other possible answer or not. Right. So we'll check with 5. Likewise, we'll check with 6, then 7, then 8, then 9. Right. And then we'll backtrack and move to the second DFS call. And here we'll check with, as we have explored 2, so we'll remove that from the list and from the sum, and we'll explore with 3. So 1 and 3. And the next DFS call will start from 4 to 9 now. So likewise, we'll have to check with every possible combinations, right? So this was the explanation part. Let's look at the coding part now. So initially, I'll create a list of lists, which we are going to return at the end. And in between, we'll have our DFS calls. In the DFS call, we'll pass k, n, our result list of lists, which we're going to populate, and our temporary list, and the initial value of the loop, which will be 1, as we will loop, initially we loop from 1 to n, right? So the initial value will be 1, which we're gonna change in every DFS call. And at last we'll pass the initial value of sum. So here we'll have the helper function. Int k, int n. We'll have the result. We'll have our temporary list. We'll have the start value of the loop and the sum. Initially, we'll check if sum is greater than n. If sum is greater than n, we don't need to explore any further. We'll just return from there. If sum is not greater than n, then we'll first check if temporary list's length is equal to k or not. If it's equal to k, we'll check sum is equal to n or not. If sum is equal to n, we'll just add temporary list to our result. But we have the reference of the temporary list, so we need to create a list here, a new list here. And we don't need to explore any further, so we'll return from here too. And if these two conditions are not satisfied, then we will have our loop, which will start from 1 to 9 initially. The start value is 1, which will go to 9. Yeah, which will go to 9. And inside this loop, we'll add I to our temporary list. Then we'll go to the next DFS call, in which the start will be I plus 1 and the sum will be sum plus the number we have taken here, that's I. And when we backtrack, we'll just remove the last element. Right, so I think this should work. And it does. So let's just submit and test this. And it works. So don't forget to like and subscribe. See you next time.
Toto down my shoes, Euro step my move. I just caught the ring, yeah, my fingers hold on the finer things. That's just what I do. When in down like 3, me and my brother shoot. Toto down my shoes, Euro step my move.